Hi guys, so as always when we start I'll keep reminding you about our Facebook page and also our Facebook group where I make videos live, so you can watch my videos there live where you can ask questions and then I can answer your questions. And then again I would like to tell you about our competition also. So we have our competition on Wednesday, every Wednesday, when you can win a prize from 20 rands up to 500 rands. So feel free to join us. If you don't know how to join, you can simply type maths and science top dogs in Facebook, and then you are going to find our group here. So after finding our group, after you joined our group, and then you can ask to join our competition. Then I will show you how you can join our competition. Okay, so today we're doing a vertical projectile motion. So in this video I'm just going to do an introduction, and then in the next video it's where I'm going to get into actual business. Okay, so when somebody is talking about a projectile motion, it can be something that's strange when you are not used to concepts of physics. But if you are used to, then something that's going to be something that's funny, because projectile motion is something that we are doing each and every day. So each and every day we do projectile motion. When you throw anything up and then that thing falls back again to the ground, that's a kind of projectile motion. So projectile motion, if something is projected, that means it's thrown upwards. If this ball is thrown upwards and then at a certain point is going to turn and come back to the same height, this is a projectile motion. This object is projected. So a few concepts that you must understand in projectile motion, because we're going to do past papers also. So we are going to come across with this term free fall, free fall now and then. So here we're going to define what's a free fall and explain to you what's a free fall. So a free fall is when an object is falling to the ground. So how that object is falling to the ground? Remember that when you throw an object upwards, it's going to come back down. So what's forcing that object? Let's say this is a ground here. So if it is a ground here, you release an object from a certain height, this object is going to fall down. So what's causing this object to fall down is a force of gravity, and that force of gravity is driven by the gravitational acceleration, which was found by Galileo Galilei first, and then Newton took that further. So it's 9.8. So 9.8 is the acceleration due to gravity. So this is acceleration due to gravity, 9.8, always pointing downwards. So anything that's above the ground is experiencing 9.8 acceleration. So only if we ignore the effect of a friction, the acceleration of that object is going to be exactly 9.8. So what happens when you release two objects that they have a different mass? So let's say you have this one here, which is object A, and then you have this other one here, which is object 2, 1 and 2, and then which one is going to hit the ground first? These two objects are going to hit the ground at the same time. Why? Because the acceleration due to gravity is 9.8. Only if we ignore the effect of air resistance, we ignore air resistance air resistance resistance only if we ignore the air resistance, these objects are going to hit the ground at the same time, because they are released from the same height. So free fall is when an object is falling to the ground due to the force of gravity only. So if any object is falling while it's expressing 9.8 acceleration, was saying that that object is in a free fall. So we can write the definition from free fall here. We can write that because free fall is when an object is falling when an object is falling due to gravitational acceleration only. Or you can just say in a simple way, it's when an object it's falling due to the force of gravity only, due to gravitational acceleration only, or due to the force of gravity only, due to the force of gravity. Instead of this, you can write force of gravity only, of gravity only, due to the force of gravity only. So that's what we call a free fall. So free fall is one of concepts that we're going to use most. So this is how you define free fall. I told you that it doesn't matter how big the object is, but it does matter how many force the object is experiencing. So if object is falling, it's falling under the influence of force of gravity only, we're saying that that object is in a free fall. So the second concept that we are going to cover, it's air resistance. So the second thing that we must take into account is air resistance, because in reality in reality you know that when you throw an object up, the bigger objects tends to hit the ground first, while the lighter objects tend to hit the ground last. So why that's happening? Let's say here you have a paper and then you have a stone. So this is the paper, this is a stone, and then you release them. So which one is going to hit the ground first if we're considering the air resistance also? So the stone is going to hit the ground first. This stone here is going to hit the ground, this is a ground first, while the paper is going to hit the ground last. So if the stone take 4 seconds, the paper can take 1 minute to hit the ground. Why? Because of air resistance. So how does the air resistance affect the falling object? So when an object is falling from a certain height, where that object is experiencing a force of air resistance. Let's say we have some parachute shooter here. So this person it's falling from a certain height. So this is the height, while this here is the ground. So while this person it's a parachuter, while this person just got off from the helicopter, the parachute is still back here, so that they haven't yet removed the parachute. So as they're falling, at some point they're going to be here, they're falling, at some point they're going to be there, so they're going to fall like this, so at some point they're going to be there, and then at some point they're going to be here, at some point they're going to be here, and then at this point they decide to take off the parachute. So now they have the parachute on, so that's the parachute is on now, and then after that, now they're here at this position. Now they have to lower the parachute, and then now they're here, they're standing here. So let's analyze the motion of that person. Remember that in grade 11 you learned about the force of a free body diagram, right? So when they're here, how many forces are acting on them? One force is acting on them, which is going upwards. This is a force of air resistance. And one force, which is long, is going downwards, which is a force of gravity. So when this is this position here, so when they're in the second position, we're going to take that as this position here. So when they're in this position, they reach a certain point where the force of air resistance is equal to the force of the gravitational force, because they're falling. So at this point here, the force of air resistance, where they're on the ground, the force of air resistance is 0, and then they have only one force. So the only one force that's acting on them is a force due to gravity. They have no force that's going upwards. So what's going to be acceleration at this point where the acceleration points? So remember that we said that F net according to Newton's second law is equal to ma. So here, since this one that's going down is greater than this one that's going up, therefore the acceleration is going downwards at that point, the first point. So the second point, since this is equal to that, so the F net is going to be 0. So if the F net is 0, therefore this one here, the acceleration at this point is 0, and that's what we call a terminal velocity. If acceleration is 0, therefore the object reach what we call a terminal velocity. So terminal velocity is where it's when the object that's under free fall, it's not the velocity of the object, it's a maximum velocity that can be reached by a falling object. This is a maximum velocity, velocity that can be reached by falling objects. So any object that's falling while it's experiencing air resistance can reach what we call terminal velocity. It's where the F of air resistance is equal to the F of the F due to gravitational acceleration. So this is what I have for you guys up so far, and then in our next video we're going to solve problems of projectile motion using kinematics equations. Okay, thanks for watching.